Hi, my name is Shagun and I'm going to walk you through my final assessment for the Machine Learning Foundation for Product Managers. The assignment that I was given was to build a model to predict electrical energy output of a combined cycle power plant. I was given 9,568 observations which represented the hourly average ambient environmental readings for sensors at the power plant, and I had to use those to plug into the model to determine prediction for net hourly electrical energy output. So I have used temperature, ambient pressure, relative humidity, and exhaust vacuum as my inputs or my features, and I had to create predictions to determine what the predicted net hourly energy output would be for any given variable submitted. To the guidelines for this project was first that I had to predict what type of ML project approach would be best for this. Second, to determine what possible features would be best if all were needed or if some could be removed to simplify. Third, then I needed to split the data to create a test set and then to determine the multiple different models if a fixed validation or cross validation test would be used. In my case, with a fixed validation set. Fourth, use that validation to compare at least two different models. Fifth, then evaluate performance on my final model selection. The steps I went through, the best approach that I landed on was multiple linear regression. It determined that each feature was well known, that they were numerical, but they determined that they had a relatively linear relationship and would not require any hyperparameter turning for feature selection. And I started by testing all features and I assessed correlation to determine if all features were necessary. I utilized fixed split validation. I split it in 16% test data and 84% training data. I validated two different models. One had four features and the other had three features. To see it was simplified, resulted in relatively similar accuracy, or if accuracy dropped, having less features. I used R square to validate these models, and for final model evaluation, I used mean absolute percentage error to evaluate. The first model I created had a test sample of 1568 observation. I used all the variables available to predict perceived or energy output of the power plant, and I had an R square value of 0.929 and approximately mean absolute percentage error of absolute about 0.008. After doing that, I tested the correlation of all the features to determine if all of them were necessary, and relative humidity showed that it wasn't highly correlated to actual energy output. So then I decided to create a second model. Omitting that feature and the output of that test using the same test sample resulted in R square output as 0.917 and mean absolute percentage error as 0.00849. So slightly less accurate in this model. So I decided that my initial test using all of the features available was the best approach for this with a multiple linear regression model. Very good performance, easy to identify variable outputs, highly interpretable. Thank you for your time.